Hello. How's everybody doing? Good? Awesome. Great. Who has heard of Flutter before? Sick. Who has used Flutter before? Maybe in a project, once or twice, the example project. Perfect. I see like half of the hands go up. Perfect. So we're going to talk about Flutter today, which is really cool and exciting. So that's me. This is Flutter After Hello World. I'm Jay. Hello. So let's first go over who I am. As Mira very kindly introduced, I am Jay. I'm a Dart and Flutter GDE, and I do freelance work for Flutter as well. Or I work with Flutter as a freelancer professionally. I am the admin and a head of GitHub over at the Flutter Community organization. I've been doing Flutter for about 2 years now. Started as a hobby thing and then went to more professional. And I'm the writer of a Visual Studio Code extension called PubSpec Assist, which if you use Flutter, you may or may not know. I already saw a couple of hands go up about what Flutter is. For the people that don't, yeah, great, welcome. So Flutter is a portable UI toolkit. It's a way to build apps, or at least the front end and some of the back end stuff as well. So it's open source and made by Google, obviously. And it allows you to deploy native apps on any platform. So that includes iOS and Android, and currently also the web, but that's still in preview. And you can compile it for desktop as well, although that's not officially supported yet. It's high performance because of the fact that it runs native code, and it also has its own rendering engine, which means that it doesn't use the native UI components that are already on the platform, but rather it uses its own components called widgets. And because it has its own rendering engine, which is called Skia, which comes from Google Chrome, you have complete control over your screen. So you can, if you want to say this pixel is going to be red, it's going to be red. You can paint your own UI if you want to. So you have a lot of control there, which also comes with nice performance gains. So what I wanted to do in this talk is say you have a Flutter project, you had it running, maybe you did the example app, which is the counter app, which many of you probably have seen. Maybe you've made an actual project for yourself, for your hobby, stuff like that. Like, what are the next steps to take? Like, what's the next step to take in order to advance in Flutter development? That's what I want to talk about today. So first of all, IDE. So this is your editor. This is where you're going to be doing most of your programming regularly. So I think it's sometimes underrated, like what you can do with an IDE if you configure it properly. So first of all, choose your editor. You have a bunch of choices. Mainly the two most used ones are either VS Code or IntelliJ or Android Studio. They're sort of the same product. So first choose one, or you can use any text editor you want. It doesn't matter in the end, although the actual IDEs have some nice tooling assistance, but you can use any text editor. It's all code after all. Then learn your editor. So this means three things for me. First of all, install extensions. So there's the official Dart and Flutter extensions for both the VS Code and IntelliJ that offer a lot of great gains as far as like performance goes. Or rather, if you want to do performance profiling, so you want to see how fast did this function run, or when is my build method getting called, or what's the widget tree like you can visualize all that with these extensions. Then, because you don't have those extensions, you have language support, which means that you now can set breakpoints for yourself, which means that, as you probably all know, that your code will stop at a certain point where you can check out what's going on. And then there's hotkeys. So there's a bunch of hotkeys and shortcuts that you can use. I am a VS Code user myself, so there's a lot of shortcuts such as swap with child or wrap with new widget. That kind of stuff really helps your workflow so that you don't have to mess with cutting and pasting code all the time. And then use linters. Who uses linters regularly? That's always too few. Real short, what a linter is basically a set of rules that you tell your code base to adhere to. So stuff like don't allow null values to be explicitly defined, always define return types. These are rules that you tell your code base needs to have. And then the linter will enforce those rules. What that means is that your code is in general cleaner because you tell yourself, hey, these are the rules that my code needs to use. And if you don't, then you'll get a red line and you'll have to fix it. The other thing is that it's consistent, so it makes for consistency, which means that as soon as one part of the code base does have return types and the other part doesn't, that will also not work, which will make for better consistent code. And it's more readable that way because of its consistency and its cleanliness. So use linters. Dart has a linter. It's called Dart format or Dart lint. You'll find it. So now that you've got your IDE set up, let's talk a little bit about the tooling. Now specifically, I'm going to go into the Flutter command line interface. So if you're using a regular text editor to do all of your Flutter work, then this will come in handy. So first of all, it's Flutter run, and this is like the general sort of command that everybody uses to run your Flutter project. What not a lot of people know, but as soon as you look it up, you'll see, is that you can add a device ID, and that will run Flutter specifically on that device. So if you have multiple connected, you can say, hey, run it on this device. Then there's packages get or pub get. Packages and pub in Flutter are the same thing in every command, so you can use them interchangeably. This will get all the dependencies in your Flutter project, and once you do that, you can run your project with all your dependencies A-OK. Then there's Flutter devices, which will list all the devices that are connected. It will give a name, it will give the ID of the device, and what platform it's running, iOS, Android, web, Chrome, that kind of thing. Then there's Flutter Doctor. You'll see this a lot when working with, when troubleshooting and stuff. So Flutter Doctor will print out a log of everything regarding Flutter on your computer. So this will tell you about what IDEs you have installed, what runtimes there are, what commands you can run, and maybe if there are some errors, maybe in general in your configuration or in a specific project. This way you can find out what's wrong. Then there's Flutter Analyze, which will analyze a specific project. So that means that it will do analysis on that certain project. If you're using a regular text editor, for example, without linters or code completion, you can use this to scan your entire project for errors that may appear, either syntax errors or formatting errors through Dartlint. And lastly, there's Flutter Clean, which will clean the build folder so you can do a fresh build, which I think we all understand. Then there's widgets. So I assume that many people who have tried Flutter knows what widgets are. So widgets are the bread and butter of Flutter, as Google likes to say. And that's sort of true. So almost all UI in Flutter is a widget. Not all widgets are UI though, and I'll get into that in a minute. So first of all, widgets are by definition basically immutable classes and plain old Dart objects. So they're not different from other classes except for the fact that they extend either stateless widget or stateful widget. Now both stateless widget and stateful widget are immutable, but I'll get to that in a minute. And composed together through nesting these widgets in sort of like reactive UI programming structures, we get UI. So that's how your UI is built up, by composing these widgets, either stateless or stateful. But what I see many people takes a while to realize is that these are just regular classes, which means that they can do anything other classes can, which means that there's a whole bunch of stuff you could do with them to increase your workflow and make it prettier. So parameters are pretty basic. Here I'm constructing a button and giving it a title with a string of submit and then giving it a color. So those are named parameters, which you'll see a lot in Flutter. Then there's functions you can define. So instead of having a button with a callback right there in the UI code, you can lift that up and just put the onTap method in the constructor of the button, and then just define your onTap method somewhere else to keep it nice and clean. And there's getters, which I use often to take data that's passed into the widget and reformat it in some way and then pass it back on. So in this case, let's say we have a list of names. I can take the first three, and then whenever I query for that displayed names, I get the first three names that were passed to the widget. Simple enough. So basically, it's a class, but it gets more interesting. So there are built-in widgets in Flutter, actually 3 packages. One is Material, one is Cupertino, and one is Widgets. Now, Widgets, the last one, is just a general package with generic purpose widgets. This is stuff like not UI, but more functionality. So, for example, gesture detector is one. And gesture detector allows you to wrap it around any other widget and allows you to detect on-tap events, for example, long press, short press, or swipes, that kind of stuff. So that common functionality is in a widgets package. Then there's Material, which is basically all UI, which gives you material design-related widgets, such as your regular buttons and app bar and scaffold, all that. And then Cupertino is the same, but for the iOS design language. So you get your typical sort of page view and scaffolding and tab bars and all that. So depending on what kind of look you're going for, you can choose either 3 or combine them, because Material and Cupertino also use this widgets package. Remember this phrase for the rest of your Flutter career, because it's going to come along, it's going to happen a lot. So whatever you're trying to do, there's probably already somebody who did it for you. And this goes for a lot of things, but especially when starting out with Flutter. There's a widget for that is the most common thing that we say within the Flutter community to newcomers, because there is. So any functionality that you might want to implement, or mostly UI actually, is already there. So have a good look at what's already around in these 3 packages to see if you're not reinventing the wheel. And if you're not, then there's always the alternative that it's found somewhere else. So almost all UI is composable from the existing widgets, even like custom stuff that looks fancy and not at all like your typical Android app. That also comes from, you can also get that from these packages. But if something's missing, you can still find it on well-maintained packages, so third-party packages. Do be careful as soon as you import a package that it's well maintained and the code is okay and it works properly, because in certain edge cases, if you import packages that are not well maintained, what you'll get is that it's more of a headache that you're fixing someone else's code rather than doing it yourself. So be careful. But in general, if something's missing, look for a third-party package and you're A-okay. There are multiple types of widgets. Now, this isn't clearly defined. Just like the React world, Flutter in general likes to use smart and dumb components. I would say it's more subtle than that. So I would make 3 divisions between these types of widgets, and that's visual, layout, and functional. So visual would be a button, for example, or a piece of text. Layout would be center is a widget that centers anything that's inside it. List is a list view. Or rather, list view has a list, and then stuff like layout builder, which allows you to rebuild your UI as soon as something about the layout changes. And then there's functional, so stuff like inherited widget, which allows you to pass objects down the widget tree. I would say that's functional. Gesture detector, which allows you to, detect gestures, is also something functional. So I would divide it like this, but there's not just UI and widgets, there's more functionality. But because there's multiple different disciplines within all of these widgets, composability gets really nice as soon as you start nesting them. So state management, this is sort of the subject in the Flutter world, and it's been for a while, because there's a bunch of state management techniques to use. Who knows some of these? Maybe Redux, for example, or Block, they're very popular. Now within the Flutter world itself, Provider is also pretty popular. I saw a couple hands go up when I asked. So my question is, which one of these is the best? Does anyone know? Shout something if you believe one. He's right. So none is best, and that's really frustrating for people who are trying to look for the best package, because there is none. So in general, it depends on the project, which is exactly what you said. But there are certain guidelines on what you can use to choose the best one for your project. And whenever I'm starting something new, I consider 3 things mainly. So first of all, does my app need to be online all the time? So this means, as you're probably familiar if you used Flutter before, stuff like online live streaming data is a very good task to use streams with. So streams allow you to asynchronously fetch data over time. So you get multiple values back. Say you have, I don't know, a messaging app, a chat message app. So those messages are coming in at seemingly random times, asynchronously. So that's great for streams. So there are a couple packages like Block and Provider, I guess. And they work very well with streams to get your data asynchronously and then rebuild your UI on top of that. If you don't need that, if you just need to fetch some data and then you're done, then stuff like Redux or Change Notifier might be fine for what you need. So that's something to consider first. Then you get, what state management pattern do I and my team know? And that's really important, because if you have the choice between, for example, Block or MobX, and you already know Block, go for it and just try it out. I mean, you'll only know by actually doing it. And then how complex is your app? So for a lot of things, it seems like people can, if you're making a small prototype, for example, and it won't grow right away, then something like Change Notifier, which is already baked into the Flutter framework, it's right there, might be enough to do simple state management, right? It's better than passing everything down the tree all the time. but it still allows you to do some form of state management while not being over-engineered, which is what people do a lot, including me, still. So that's sort of into state management. So make those, try to check that out if you're struggling with it, and try it out mainly. Then there's backend, which is closely related. So this is a question I get asked a lot: how do I hook up my backend? What's general patterns and stuff? Here it's very nuanced again, but in general, these are the rules that I follow. So, or rather, the facts. So Dart is a general purpose programming language. So it supports a lot of protocols, such as HTTP and gRPC. So you can implement gRPC in Dart, and there's a package for it. And HTTP is built right in, actually. So if you have a need for some sort of HTTP API, fetching some data, doing some puts or fetching whatever, it's all there. So you can just build your API, make a wrapper for that, and then you could be done. Now, one thing to differentiate is there are two HTTP clients, which not many people realize, which is bad, so I'm going to fix it. One is the package HTTP. Most people will be familiar with this one. So this is really simple. You just say http.get, and you get back a string. That's it. Then you can deserialize that string into JSON, and you're done, basically. You can give it a headers, and you can give it a body if you're doing like a put or a post. That's fine. So that's for simple APIs, I would say. But there's another one, which is HTTP client, which is already built into Dart. It's right there. So you don't need to import any external dependencies. And that allows for more fine-grained control. So for example, the HTTP package at the moment of recording only returns, say you want cookies. So this can be a common use case. You want to log someone in through a regular web API, but you're using cookies and you want to do stuff with a web view, for example. You need that cookie. So as soon as you try to get that, you'll see that it's a string. So you have to deserialize that yourself. It's a whole bunch of hassle. But the HTTP client, the actual Dart one, gives you cookies as their own object. So you don't have to do any serialization or deserialization yourself. It also allows you to fetch all the HTTP data as a stream rather than a single value, which might be nice if you want to do stuff asynchronously. But in general, if you just need to get a data, most people will be fine with the HTTP package. And if you want to have more fine-grained control, try to use HTTP client. It's a bit more verbose, but if it works for you, then fine. Then there's also something important where don't reinvent the wheel again. So for example, if you're using Firebase, just use the Firebase package unless you have a very good reason not to. This goes for a lot of things. So there's Objectbox, which is also a database platform. They now also have a plugin. So if you can use that, use that. SQLite has its own plugin now, so there's a lot you can do. There's a lot you can do with the plugins that are already there, such as Firebase. But if you need to make your own, then you can. Use whatever pattern works for you. With that, I'm saying like there's no right or wrong way. I guess there are wrong ways to build APIs, but there's no best way. Depends on the project. I really prefer one pattern, which is an abstract API class and a repository pattern, which means that your front end will for everything that it needs, we'll call a repository, and a repository class or instance will keep track, will call the API, and will cache everything if needed. That's the basic explanation of that pattern, and then you abstract away that API class so that you can have an actual API and a mock API and maybe another one if you need to change in the future. That's one way to do it, but there's a bunch. So experiment and look up samples because they're good. Then, almost lastly, there's packages. So I've been talking about packages before in Flutter, and sort of this is how they work. So you extend your app's functionality by importing existing code, which is what a package is, which I guess we all know. If you've ever used most programming languages, this is just packages and imports and all that. These ones can be found on pub.dev, so that's the official website where all packages can be found. There may be one or two that are only on GitHub, but you can import those as well. But most of them will be on pub.dev. There you can find examples, how to import them, the source code, everything. And you use it using pubspec.yaml, which if you've done the workshop before, you know pubspec.yaml is the file where most meta information of your Flutter app is described. For example, the name of the application, the version, the build number, the author, the dependencies, the development dependencies that are only needed while debugging, all the assets, all that is there. And to add one, for example, the camera plugin, you just literally give it a dependencies, a sort of, if you know JSON, it's JSON, but less noise. So you say dependencies, and then you indent to say that this is a list, and then camera, colon, and then the version number. Control S or Command S, it pulls in the dependencies, you're done. So that's how simple it is. And then small plug, I made PubSpec Assist, which is for Visual Studio Code, where you can just search for the package right there. It will import it or update it for you. Small plug might be nice. I use it all the time. So a lot of these packages will add functionality, and that can sort of come in two forms mainly. So there's the pure Dart packages, which which are written purely in Dart. So these are usually state management patterns or UI, stuff like that. But then there are also packages that are plugins, and those add functionality on a more native level. So most packages are plugins on pub.dev because they're basically, well, let's get right to it. Plugins allow two-way communication between Dart and native platform. What that means is that if you have some API that you need to access from Flutter, you can write a plugin to be the link between that part of Flutter and the native API. So that allows you to do all sorts of things, like call native APIs that you've already written or that are only available for iOS and Android, for example, to call them from Flutter. So what you usually do is you have a class with a bunch of methods, sort of like an interface, and then you can access that from Flutter because it's just a Dart file, and that will call the methods within Java or Kotlin on the Android side and Objective-C or Swift on the iOS side. So you write the definition, sort of the class, the Dart side, and then you write the iOS and Android side, and then it's all abstracted away, and you hopefully never have to look at it again. So that allows you to wrap existing APIs. This is what a lot of people had trouble with. So I already have an API for iOS, and we have one for Android. But now with this Flutter thing, we can't use that API. Well, you can. You just write a wrapper, and then you're done. Assuming that those APIs work the same way, which I hope they do. These are very common plugins. So these are packages on pub.dev, but they're also plugins because they go to the native APIs. So camera needs to access the native camera APIs to get the image stream data. Bluetooth obviously is a hardware part, so it needs the native APIs for that. Connectivity will tell you if the user's phone is or device is currently connected to the internet, and it needs that internet activity plugin or API from the native side. And Firebase is not native in that sense, but it's a wrapper, so it uses the native APIs for iOS and Android instead of rewriting the whole Firebase package again. So these are the most common plugins. So that's most of what I had to say. My main thing to leave you with here is go explore it, do stuff. Basically, by experimenting, you'll learn. And if you come across problems, then look them up and ask questions. Because, yeah, because, I mean, if you don't, then you're going to get stuck, and you're going to be looking at Stack Overflow code for 2 days straight. So please go out there, do stuff, and have fun while doing it, which is important. So thank you. That was my talk. You can visit the slides over at jfk.dev/talks, and I hope you enjoyed. Thank you. Q&A. Cool. Right?
Yeah, we don't have questions in Slido yet, but yeah, you can just raise your hand and ask Jay any questions you may have.
Go ahead. Yeah. Mm-hmm. Yeah. So Flutter is just a framework on top of Dart. The question, by the way, was Dart is used for the front end of Flutter. What's used for the back end, basically? Dart is used throughout because the only thing, Dart is just a general programming language. Flutter is just a package on top of Dart, so a framework built on it. So what you'll do is you'll have your UI code, which is Dart, because that's what Flutter is written in, and then your backend stuff, which maybe in another folder within the same project, will also be Dart code. It's all Dart in the end, but it's just how you use it is different, because you don't want to mix backend and front end within the same file. You can, but you want to separate them properly. So what will usually happen is you'll have I'll have two folders. So you have your source code folder, that will have like one folder called UI or UX and one folder called Backend, and then I separate everything in those, and then they call each other through the repository pattern that I explained before. So yeah, a lot of choice on how you approach it, but it's all Dart in the end. Anyone else? Go ahead. So in my experience, first of all, the repository pattern based question was, how do I scale Flutter apps, or how do businesses in general scale Flutter apps? And that the answer really depends on what you've been doing in the first place, like what patterns you're going for. You can make an app that's unscalable within a week, but if you do it properly, you can scale just like any other framework. So that repository pattern, for example, I use that professionally, so I build Flutter apps using that pattern, and it's sort of proven to be good to me. So it can expand because there's a few nuances in how that pattern works. It's not exactly, well, it is what it said, but it's not everything. So, but there are examples online of how to actually use it. So, yeah, Flutter apps can expand and grow like any other framework. It's just how you approach it, but that goes for any framework, I guess. And with that repository pattern, I found that it works quite well, but you can use anything you want in the end. Does that answer your question? Cool. Anybody else? Do we have questions on the thingy-majig? No, is that it? Perfect. Well, that's a great sign, I guess. Thank you all very much for listening, and I'll see you around.